Hi everyone, I am Shashank Jain, an Iris app developer from the batch of 26. Welcome to the fifth session of the Flutter Bootcamp. Today we'll learn about state management in Flutter using BLoC. So before we begin, let us try to understand what is state of an app. In very simple terms, whatever data you need to rebuild your UI at any moment in time is termed as state. For like in context of Flutter app, it represents the information that can change over time and influ that influences the appearance and behavior of the UI. So for example, let's say a user inputs some data that could be one of the states, or he fetches the data from the API that could be one of the states, or maybe an error occurs while fetching the data. So these are the multiple states that we need to handle in the apps. There can be many such states. So with state management, we handle these multiple situations or states, keeping the UI in sync with the application's logic. In Flutter, the UI is typically divided into widgets. So with state management, we basically try to update these widget accordingly. With good state management, we try to ensure that whenever a change occurs in any part of the app, it is reflected in all the other relevant parts of the UI. So BLoC is one such state management library that helps us achieve this. It provides us a structured way to handle the different flow of data and events within our app, and which makes our code base much more cleaner and organized and maintainable. So what BLoC basically does is, for every event that UI triggers, it listens to it. So this is basically a stream which BLoC listens to and processes that events accordingly and emits out states for each event that occurs. So when, let's say, you press on a button to fetch your profile information, so it emits out a fetch profile event. The BLoC listens to that event. It goes to the repository is basically, let's say, a class which has the code to handle to get your information from the API. So it calls the fetch user info function from the repository. The repository responses with either your user profile or an error. Then BLoC handles that response and emits out an state which is displayed to your UI. Now, once you have a basic idea of how BLoC works, what exactly is happening, let us look at the example app that we are going to build today. So in this app, this is basically a very simple app which I am using an external API, so please ignore the data. What we are going to build here is this displays all the tasks that are stored in my database. Uh, I can add new tasks to this, uh, and I can mark my task as completed or they are still ongoing. Now, whenever user logs in, it fetches the data from the API and displays it to the user. This is what we are going to build today. Before we begin, I'll just show you what packages I'm going to use in this tutorial. I'll, so if you see, I'm going to use the build runner to generate my JSON files. We'll see it later. Then I'm using the equitable package. I'm going to use the Flutter block package, the HTTP package, JSON annotation, and JSON serializable package. And for the extensions, I am going to use BLoC extension. This is provided by Felix Angelov. He's the creator of BLoC. Okay. Now let's see how we are going to work on this app. I have pre-written some code so that we don't have to go over the boring stuff. So I'll just go through whatever I've written up till now. So I've created a very simple app uh, has which shows error no task found and a floating action button which opens this dialog box and nothing else. Now let's see what I've written. So I first declared a material app I've wrapped around my home widget over it, and I've declared the theming of the app. Inside my home widget, I have two text editing controllers for the dialog box field, and I have disposed them here. You should always dispose the editing controllers whenever they go out of use to prevent memory leaks. And I call init state. So init state basically initializes the controllers as soon as the widget is put into the widget tree. Then I have a scaffold, an navbar which shows your task heading, and I've styled it. And in the center, I just show this widget, and I have a floating action button for opening my dialog box, which I call through the open dialog box function, which in return calls a show dialog box function, and which builds an alert dialog box here. The alert dialog box has two text fields. The first text field for task title, the second for inputting user ID, and two buttons to either cancel the task editing or to add the task. Then I have a basic task model. So here I've written a custom entity to transform the data retrieved from the API into our custom entity. So what we do is, what it has is task ID, a user ID, a title, and bool whether the task is completed or not. And then I initialize all these using the constructor. Then I've also written a copy with method. We'll see how we use it later. Then we have a from JSON method. So this method basically transforms the JSON input that we receive from the API into our custom entity. I am using JSON serializable package to generate the code for this. It generates the boilerplate code, so I don't have to write. This is the boilerplate code. Uh, I can just reuse the from JSON and to JSON method using this. Now let's look at our repository. So inside the task repository, I have defined my base URL. This is the API endpoint that will be hitting to get uh, the tasks from the database. Then I'm using HTTP package to call the get method on this endpoint, and once I receive a response, I check if the status code is 200, and if it is so, I transform the received response, I decode it, and I decode it into a list. So basically the API returns me JSON containing a list inside which there is a map containing information about each task. So I first decode my JSON as a list, then inside the list each item is further transformed using the task.fromJSON method into our custom entity task, and then I return all the transformed item to a list, and I return it from my getTask function. The getTask function is a future because I'm awaiting for my response, so it basically returns a future. And if the status code is anything other than 200, I throw an exception saying that it failed to load my tasks. Now let us look at our BLoC. So we'll begin implementing the BLoC. For BLoC, we basically define three files: the state file, which contains all the states that our BLoC will emit; the event file, which will handle all the events; and the BLoC file, which will map those events and their functionalities. So the state file is part of our BLoC file, and so is an event file, and we say that these two are part of the BLoC file. Now, now we'll define the very first state class. So this is basically the base class that our individual states will inherit. It extends equitable so that our task state objects are value objects instead of identity objects, and then we can define individual states inheriting our base state class. So the task loading state is one such state, and the other state could be task loaded state. So this will basically represent when all the tasks have been loaded, and it will contain a list of our tasks, and this we will emit, and we are passing task, so we are passing this list as a value to compare. So whenever two task loaded states are compared, we'll compare if the task list is different from the previous, from the other object. This will come in handy when our UI is getting rebuilt and Flutter has to decide whether to rebuild the UI or, or not, based on whether the task loaded state is different or is it same as the previous state. Then we have the task error state. So whether an error occurs while fetching the data, will emit this state. Now let us define the events for our app. So again, this will be the base class for our task events, and we'll define each event which will inherit this task event class. The load task event. So this event will basically load all the tasks from the API. We'll call this event to load the task. Then we'll have add task event. So this will add a new task to our uh, database. And then we have update task event. So when we want to update any task, we if we want to update whether it is completed or not, then we'll call this. And the delete task event. So if we want to delete a task or not, we won't be implementing this, but this is just to show you guys how different events might be defined. Okay, now let us look at our BLoC file, which will define all the mappings for our events. So the task BLoC class will contain all the mappings that will define. It uses task repository to call the get task function. Will pass the task repository in the constructor of our BLoC. When we create a BLoC, we'll pass the task repository in it, in this. Uh, Now this line basically defines the initial state of our BLoC. So as soon as the BLoC is created, this is the state that our app will receive from the BLoC. Then we have defined what should happen when each event is called. So this basically tells that when on load task event is called, then call this function. We'll define this function soon. Similarly, when add task event is called, call this function. Okay. Now let's see, when onload task event is called, uh, we'll first emit the loading state. So we'll say that our tasks are loading, we are fetching the task. Then we'll call the get task function from using a repository, and since it returns a future, so we are awaiting for it. And once we receive the task, we emit task loaded state, and we wrap it in a try catch statement, since our repository might throw an exception. So we catch it here, and if we catch an exception, we emit a task error state. Now this is the on add task. So when add task event is called, we call this function. This is basically the mapping for our event. And when add task occurs, we what we do is, if our current state is task loaded state, so if our current state is task loaded state, then we have access to the list which contains all the tasks, right? So we use that list to we add a new task into that list. Now, how did I get this task here? So when I defined my add task event, I defined a final task uh, variable. So and I pass it in my constructor. So when I call add task event, I pass my new task in the constructor and I can access it here using this event.task, which is basically the variable for add task, and we access the member function, a member variable for it. Then similarly, we have the delete task function, and then we have the update task function. We won't be using this in the app, but this is just to make you guys understand how the mapping works. And on update task, we'll just use it to update whether our task is completed or not, but we can extend it to edit the titles or user ID and many more stuff. So what we are going to do is, we from the list of our all the tasks that we have it access we have access to that list because we have emitted a task loaded state. So we have access to a task here. Then from each task we map that task. So what we are doing here is, we are for each task in our list, we are checking if the ID of our current task and the task which emitted the event, which emitted the update task event, if that matches, then we replace that task with our event task. Otherwise we keep the same task in the list. Now again, how did I receive this task object here? So in my update task class, I had defined a final task member variable and I receive it through the constructor. And yeah, so this is basically it, how we define the block, the mapping for blocks, the events and the states. Now we'll look at how is it integrated with the UI. So first thing that we need to do is, we need to create an instance of our block that can be accessed throughout the particular route that we are currently in. So first of all, what we are going to do is, I'll create a block provider. So what block provider does is, it provides the block instance to my widget tree. Now one thing to note here is, it always provides the instance in a single particular route. It won't provide the instance in multiple routes. We'll look at how that is exactly working. Uh, so what I am doing here is, I am creating a task block instance which will be accessed by my entire widget tree, and then I am also calling a add task event on that instance. Let's understand what this add is. This add is basically a function which is provided to us by BLoC, and it lets us call the events accordingly. So this is basically calling a event on this particular instance of our block. Okay, now once we declare our block provider, our widgets can access this instance of our block using the context itself. So what is context? Context is basically a address which defines where my widget is in the widget tree. So it basically works in a bottom-up approach. So if I am the fourth widget in my widget tree, fourth widget down the widget tree, I will go up to my parent and look where I can find the instance of this task block. We'll see how that exactly works a bit later. Now I have used multi-block provider here, although it wasn't required, but I wanted you guys to just see. This is basically used to uh, provide multiple blocks to a single widget. So I might have had an internet block here, which would emit whether what is the state of my internet in the current app. So whether is it connected to internet or not, or and stuff like that. So currently our home page is just a static page with nothing much to do, but we'll begin listening to the states that are emitted. So how do we do that? So we'll wrap our center widget, which is basically a body in our um, in a block builder, and we'll begin listening to the different states that are emitted by a block. So I'll pass my task. I'll so what this is defining is that this block builder listens to the tasks block and listens to the task state, and this builder is triggered whenever there's a new state emitted, and it checks if the state is same as the previous state or not, and accordingly rebuilds the UI. This is particularly really helpful because it only rebuilds a single widget, or a widget that is you have wrapped using the block builder, instead of the entire page, which would happen if we had used set state. Now what we are going to say is if state is tasks loaded. So if the state is tasks loaded, what we want to do is we want to display a uh, list of all the tasks. So how do we do that? We define a list view builder, uh, which will uh, which will build individual task widget, which I had defined here, which is basically a tile that I had showed you guys earlier, and will pass the individual task in that. So how can I access it? So my state emits a tasks list, so I can access the individual task using the index from that list. And what would be the length of this? uh, it would be basically the length of my tasks list. Now the second state that we need to handle is if the state was loading, right? So task loading. So you want to display a circular progress indicator to indicate the loading condition. And else if the state was else the remaining state is error state, so we'll just display the error condition error. No task. Yeah. So uh, as soon as I declared a block builder, the state last state emitted was tasks loaded state. So it rebuilded a UI calling the list view builder, and which individually builds these task widgets. But how do we emit events, right? So we want to add the functionality to our uh, floating action button to add new events. Currently nothing happens if I press add. So what we are going to do is, uh, in our open dialog function we have show dialog function. So and it builds alert dialog box. Now inside a button, what we want to do is whenever the user presses the add button, we want to add the new task to our current list. So how can you do that? We use the context that we have provided to access the block So we write context dot read, and what block are we accessing? So we are accessing task block, and then I call an add function, which basically lets me call an event, emit an event. So I call tasks add event, which is basically add task event, and what and I pass my task object that I want to add, and it will contain an ID. Let's parse it in dot try parse. Uh, okay, this will be, yeah, and this shouldn't be a null. So if the parsing fails, I'll say the user ID that generated it was 1, and whether the currently when we are adding it, we'll say the task is not completed. Okay. Now what this is doing is context.read. This is basically accesses the task block instance that our provider is providing here. Uh, Using that instance, we call the add function, which basically calls the event that a block listens to, and we pass the tasks here that we want to add. And once this is done, we pop our dialog box. So this should work, right? Let's see. I'll say task iris, user ID is 123, and I press add task, but nothing happened. Why did it not pop? uh, let's see the error. Okay, the error says that provider was not provided for this block. So okay, so this error basically occurs because we are trying to access the block instance in a different route, but uh, I am passing context here, right? But this is not the context that has my instance. This is the context that my alert block dialog box was pushed using. So show dialog box, what it does is, if we go in here, it calls the navigator dot push function, right? So what this does is it pushes this alert dialog widget into my widget tree and creates a new route. Now in this route, I cannot access my block instance. So what I need to do is I need the context of my previous route, which is my home page widget route. To so what I did was I am passing a build context in my open dialog box function. So I pass the context, this context is this same context, and I pass this context here, and using that context, if I uh, call the read method here, uh, I should be able to uh, access my block instance. So let's see. Now I click on okay. Okay. Now let us try to add an event. Okay, let's fill it again. Iris task 123, add it. Now we were able to add a task. Now to listen to the states emitted and without actually building a UI, if we want to perform some action, maybe call some function based on an event, How would you do that? So we can do that using BLoC listener. So what we'll do is we'll wrap our floating action button uh, in BLoC listener, and again we'll do the same thing. We'll provide the task block here, and it will listen to the task state and will perform the actions accordingly. So if the state is task loading, what do we want to? We don't want to perform any action. Let's say if we just want to show a message whenever a new task is added. So we'll say if state is task added or loaded. So, or maybe if the state is task loaded only, okay, cool. So we'll call a scaffold messenger dot of context dot show snack bar, and then we'll build a snack bar widget which will basically require a text widget to display it, and we'll say that your task was added. So I'll say your task was added successfully. Okay. Yeah. So what BLoC listener is doing is it is listening to the states emitted by our BLoC, and according to the state it receives, it performs some action. It doesn't exactly rebuild the UI, it calls a function that might rebuild the UI or maybe show some message or anything like whatever your app needs. So when we do this, let's see what happens. Now if I create a new task, iris task user ID 123 and add, so I receive a notification that my task was added successfully. So now we'll implement the functionality to switch between the completed and ongoing state of our task. To do that, we can just detect taps on our widget and switch the completion state of our task. So how will I implement it is I can wrap my task widget with a gesture detector. What gesture detector does is it detects any gesture that occurs on our event. So when I tap on my widget, it detects that and it can perform whatever function or event we call within the ontap function. So I'll call the onText.read and I'll add or basically emit out an event for update task, and then I'll update the state of my task for that particular task which is calling, which is detecting this gesture. So I'll uh, use the instance of my tasks block, and then I'll call the event which is update task event, and I access the task which is calling that event, and I'll use copy with method. The copy with method basically copies the our current object. It creates a copy of that object with all the values initialized, and we can update any particular value that we want in the copied object. So I'll update the is complete value, and I'll just switch the values to what the opposite state to what it was currently. So I'll access the index and is complete, and I'll just switch it. Yeah. Now whenever we tap on our widget, it should emit out this update task event and uh, change the values. So let's see. When I tap on this, yeah, the value gets updated. Okay, yeah. So we see this snack bar because uh, our floating action button listens to this, so whenever a new event occurs, this emits out uh, this task's loaded state, and we see the snack bar. We should have ideally implemented another state, which is the updated state, so that this doesn't get triggered every time. I would suggest you guys try to implement that state by yourself. That is it for today's session. If you guys have any queries, you can reach out to me, and I'll attach some documentation in the description as well, so that you guys can read up more about this. Have a good day.